The video will introduce 3 approaches for implementing the sequence game agents. Our team will discuss the key challenges and design choices for each approach. In designing the heuristic agent, a key challenge was to balance the computational efficiency with strategic complexity. The agent needs to make rapid decisions within the time limit, while also prioritize the moves by evaluating the board states and sequence potentials. The important jack cards are used in critical situations as well. Another challenge was handling imperfect information. Since the opponent's hand cards are hidden, the agent focuses on the current state and threats, which lacks the ability to look ahead and learn from experience. For example, in the pictures, the opponent forms a sequence from the side areas, and also it used the cards from the draft deck to win the game. These limitations are addressed in the minimax and Q-learning agents and will be discussed later.
In this video, I want to explain how I solved the running out of thinking time issue. Initially, the minimax agent always tend to run out of the thinking time because of numerous branching factors in each level. So what I did is basically reducing the branching factors by applying beforehand filtering. Firstly, before we jump into the minimax algorithm, you can see we have a bunch of evaluation functions which will find the most obvious actions, most promising actions that we should execute, like the immediate win and prevent the opponent from immediate win actions. After that, we do a quick evaluation check for all the actions, which orders them by scores. The lower the score is, the more important the action is. I gave 30% of the thinking time to do the quick evaluation. Finally, we get into the minimax exploration stage. I set the maximum depth to 5, and I also set the time limitations in each level to ensure that it doesn't run for too long. In the minimax limited function, I also call the quick evaluation function to get the most promising actions and passing these actions to the next level of the minimax tree, which largely reduces the number of state spaces that to be explored.
Talk about challenge for the Q-learning agent here. So after I have downloaded and watched some game replays, we play against like 307 or 309, and that I have lost, and I noticed something interesting, that they have made trade actions in sometimes that led them to have a sequence complete. So I have realized that trading is also important here. So let's look at this function. This is the find trade and win action function, that in this function specifically looks for opportunities where trading a card can immediately lead to a sequence completion. So if you look up, so in this function, which is the get best action that helps me get the next best action for my agent, we can see that find trade and win action is in the 6th place, and the first priority stuff is like check if we can win immediately, and so it has a quite good priority for trading. And let's go back. So if we look into it, so the real innovation here is the hand simulation. So for each potential trade action, the agent will first simulate what our hand would look like after trading, and check if any card in this simulation hand could create a sequence. Test all possible positions for each card using a temporary replacement, and like here, and it will check all 4 directions, like vertical, horizontal, and diagonal. I think that's actually eight directions, and after that it will give back a list of trade win actions. So like this trade strategy made a quite good difference in our agent performance, and before implementing it, our agent would often miss some opportunities, like trading trade action only still way to get rid of dead cards, but now it actively looks for trade combinations that enable immediate scoring. Yeah, and this is the challenge 4.